Good day, everyone, and welcome to Module 7 video discussion. So, before we proceed to our new discussion, let us have a quick recap of our previous module. So, in Module 6, I have discussed about the sequence, series, and the sigma notation. So recall that a sequence is a list of numbers that are separated by commas. So for example, we have 1, negative 1 half, 1/3, and negative 1/4. While a series, it is a sum of numbers, meaning they are separated either by a positive or a negative sign. And there are different types of sequence. So first we have the arithmetic sequence. So it is a sequence which each term is they have a common difference. So that is by adding a constant from the previous term. So for example, we have 3, then we have sa sunod na nga sequence is 5, then 7. So their common difference is 2, meaning you're going to add 2 by the number to know the preceding nga mga numbers niya. So 3 plus 2, that is 5, then 5 plus 2 is 7, then 7 plus 2 is 9. Next is the geometric sequence, that is by multiplying naman sa ato ang previous nga number. So for example, we have 1/4. So the common ratio here is, or the common number that we are going to multiply from our previous number is 1 over 4. So 1 over 4 times 1 over 4, that's 1 over 16. Then 1 over 16 times 1 over 4, that is 1 over 64. And lastly is the arithmetic sequence, which is just the inverse of our harmonic sequence. So if we have 3, 5, 7, 9, 11 as your arithmetic sequence, then its harmonic sequence is just equal to 1/3, 1/5, 1 over 7, 1 over 9, and 1 over 11. Okay, so for the sigma notation, so just a short recap that it is very important so that ma-minimize ang ato ang labor in writing the sums of the numbers. Okay, so for this module, so we'll be having a new topic which is all about the binomial theorem. So in this module, we are going to study two ways in expanding the term a plus b to the power of n. So where our n here is a positive integer. So that can be starting from 0, I mean 1, 2, 3, 4, and so on. So we already encountered terms like this because naka-expand na ta ani. For example, we have a plus b to the power of 2. So ang expansion ana is just the square of the first term. So we have a squared plus we multiply the first term by the second term, then we multiply it by 2. So that's why we have 2ab. And lastly is we are going to square the last term. So we have b squared. So we are going to study two ways in expanding it. So first is by using the Pascal's triangle. And this Pascal's triangle is just applicable if our n, or the power here, is not too big. Dili siya dako kayo nga number. And if we are going to determine all the terms in the expansion, so these are the terms of the expansion, just like a squared, this is the second term, and this is the third term. So if you wish to expand, example, a plus b to the power of 5, so we can use the Pascal's triangle and we will know all the terms of that expression. While the second method that I will be teaching is all about the binomial theorem. So there will be a general formula for it in expanding this expression. So again, this is only if our n is a positive integer. So this formula is very useful, especially when our n is very large. So for example, we have a plus b to the power of 30. So we cannot use the Pascal's triangle in expanding that. I mean, we can use it, but it will take so much time when we are going to use that method. So since hilig man tawag shortcut, then we are going to use this general formula, which is this binomial theorem. Okay, so the teaching notes calculations with big numbers are required in many of the examples and exercises in this module. So I will be discussing examples later in this module. And the use of scientific calculator is desirable. So if you have scientific calculator there, so you may use it to to kana check your answers or para mas madali mo solve. Okay? So, moreover, if only a specific term is required, then it can be computed directly using a simple formula. And lastly, the theorem can be used to derive and prove some useful and interesting results about sums of combinations. So, at the end of this lesson, so you are expected to learn about how to illustrate Pascal's triangle in the expansion of x plus y to the power of n for small positive uh, integer values of n. Number 2 is to prove the binomial theorem. Number 3 is determine any term in x plus y to the power of n where n is a positive integer without expanding it. And lastly is to solve problems using mathematical induction and the binomial theorem. So at the end of this module, I will be giving online seat work and online assignment. So as usual. So let's proceed directly to the discussion. So first is about the first method in expanding the a plus b to the power of n, which is the Pascal's triangle. So consider the following powers of a plus b. So we have a plus b to the power of 1. So when you expand that, that is just simply equal to a plus b. Then if you have a plus b to the power of 2, then if you expand that, that is a squared plus 2ab plus b squared. Okay, we already know that. So if we are going to expand naman, a plus b to the power of 3, so that is this one multiplied by another a plus b. So if you're going to multiply that, the result will be a cubed plus 3a squared b plus 3ab squared plus b cubed. So if you have a plus b to the power of 4, then this will be its expansion. And if you have to the power of 5, then this will be its expansion. So imagine if you have a plus b to the power of 20. So taas kayo nga terms ang imuhang makuha. So here we are going to list down the coefficients of each expansion in the triangular array as follows. So recall coefficients, these are the constant numbers beside your variables. So for the first row, this is our first row where our n is equal to 1, meaning our power is just equal to 1. Then we have the coefficient of our a, which is imaginarily equal to 1, and also our b. So we have 1 and 1. So for our second row, we have our coefficients 1, 2, and 1. So that's why we have here in n is equal to 2, or row 2, we have 1, 2, and 1. For our row 3, we have 1, 3, 3, and 1. So for our row 4, we have 1, 4, 6, 4, and 1. And lastly, sa tong row 5, we have 1, 5, 10, 10, 5, 1. So ilahang formation is in triangle, and ang combination sa tong numbers is very familiar, no? So the preceding triangular array of numbers is part of what is called the Pascal's triangle. So mag-form ni siya og triangle. So Na po yung imaginary nga 1 dere. So this is named after the French mathematician named Blaise Pascal. So that is 1623 to 1662. So mo siya nga year gipanganak and mo siya nga year nga namatay. So these Pascal's triangle have properties, and these are: first, each row begins and ends with 1. So each row, so for our row 1, nag-start siya ni 1 and nag-end po siya ni 1. Sa row 2, nag-start siya ni 1 and nag-end siya ni 1. So mo na siyang isa ka property ni Pascal's triangle. Second property is each row has n plus 1 numbers. So, ang numbers nga pasabot ani niya is the terms. So, if we have our row 1, we have n is equal to 1, then the number of terms is just simply equal to n plus 1. So, for row 1, we have 1 plus 1, then we have two numbers or two terms. So, for n is equal to 4, so the number of terms here is equal to 5. So, that is just 4 plus 1. So the third property is the second to the last number of each row corresponds to the row number. So if you observe that if n is equal to 3, so the second coefficient, which is equal to 3, and the second to the last is also equal to 3. So that corresponds the power of your, or the row of your coefficients. Okay, so the same with if n is equal to 5, so the second coefficient is equal to 5 and the second to the last is also equal to 5. So the fourth property is there is symmetry of the numbers in each row. So meaning naa sila symmetry, meaning mirror. So if 1 ang naguna, 1 pud ang ulahi. So if 5 ang naguna, then I mean 5 ang second na coefficient, then the second to the last is equal to 5. If the third coefficient is equal to 10, then the third to the last coefficient is also equal to 10. So naa siya symmetry. The fifth property is the number of entries in a row is 1 more than the row number, or what we call the 1 more than the number of entries in the preceding row. So this is just similar to kaning property sa second property, which is ang ato adong number of entries, or that is the number of terms, is simply equal to the row number plus 1. Okay? And lastly is every middle number after the first row is the sum of the two numbers above it, diba? So, sa may taas nga number ni 2, so that is 1 and 1. So, you add 1 and 1, so the result is equal to 2. The same with 3. So ang taas nga number niya is si 1 and si 2. 1 plus 2 is equal to 3. So si 4, that is 1 plus 3. Si 6, that is 3 plus 3. Then si 10, that is 4 plus 6. So that is a very useful in constructing the succeeding rows of our triangle. And recall sa to ang previous module, if you're going to find the next number using the first or the previous two numbers by adding the two previous numbers, so that's what we call the Fibonacci sequence. Okay, so let's have an example. So we are asked to use the Pascal's triangle in expanding the expression 2x minus 3y to the power of 5. So we are going to expand this. So if we are going to expand this nga mano-mano, we have 2x minus 3 times 2x minus 3y times 2x minus 3y and so on. So ikalimahon ko ni multiply. But using the Pascal's triangle, it will make things easier. So recall in the fifth row of Pascal's triangle kani-kanina, so we have coefficients 1, 5, 10, 10, 5, and 1. So that's why I wrote it here again. So we have a plus b to the power of 5 is equal to this is 1, 5, 10, 10, 5, and 1. So, sa iyahang mga variables, so we have a to the power of 5, then a to the power of 4, a to the power of 3, 2, 1, and 0. So nag-decrease ang power sa atong A while ang atong B is nag-increase. So from 0, na mo siyang 1, na mo siyang 2, na mong 3, 4, and 5. So aha man siya mag-end. So mag-end ang number sa power nga given sa nga expression. So since ang given is 5, then mag-start siya ni 5 and mag-end po siya ni 5. The next is we are going to substitute the values of our A and B. So our A here is 2x. So that's why I highlighted it by red. So para di mo maligbog. So si A mo na siya si 2x. Then our B is, since this is plus, then minus man ang atong given. So atong B is appeal si negative nga sign. So our B here is negative 3y. So we are just going to substitute the values of our a and b's here. So that's why we have 2x to the power of 5 plus, this is plus 5. So manang natay 5 times a to the power of 4. So that is 2x to the power of 4 times b. So that is equal to negative 3y. So, and so on. So ato lang nang gi-substitute ang values ni a and b. Next is we are going to simplify. So since we have 2x quantity to the power of 5, so we are going to distribute this power here. So dili lang si x ang ato ang erase to the power of 5, but appeal ang ato ang constant, which is kani si 2. So 2 to the power of 5, that is equal to 32. Then we have x to the power of 5, that is x fifth. The next is the same lang, distribute 4. So 2 to the power of 4. So pila man na? 2 times 2 times 2 times 2. So that is equal to 16. Then we multiply 16 by 5. So that is equal to 80. Then we have this constant na negative 3. So 80 times negative 3, that is equal to negative 240. That's why we have 240 here. So again, what I did is we are just multiplying and simplifying the constant numbers. So again, distribute the power sign sa atong parenthesis. So we have 2 to the power 4 and x to the power of 4. So that's why we have 16 x to the power 4 here. Then we multiply it by 5. That is 80 x to the power 4. Then we multiply it by negative 3y. So that's why we have negative 240 x to the power 4y sa ato ang second nga term. So sa atong third term, so that is 2 to the power of 3. So that's equal to 8 times 10, that is 80, times negative 3 squared is equal to positive 9. Okay, so 80 times positive 9, that is equal to 720. Then ato ang mga variables tayo natong i-add. So in result, we have this final answer nga expanded form ni expression 2x minus 3y to the power of 5. Okay, so let's have another example. So we are going to use Pascal's triangle in expanding a plus b to the power of 8. So in solution, we are going to start with the fifth row or any row of the Pascal's triangle that we can remember. So by using the previous example, we have our fifth row, n is equal to 5 is equal to 1, 5, 10, 10, 5, 1, di ba? Then, ato lang i-add ang duha ka numbers sa ilang taas, then that will be the coefficient sa tong term. So 1 plus 5 is 6, 5 plus 10 is 15. So that is for the 6th nga power. So this is for the 7th power, and this is for our 8 na power. So this will be our coefficient sa atong mga terms. And remember, if you have n, your power is equal to n, which is equal to 8, then ang terms na to ana is we just add 1 sa to ang n. So, n is equal to 8. So, 8 plus 1 is equal to 9. So, ang number of terms is 9 kabuok. So, if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, sakto ang ato ang Pascal's triangle. That is just for checking lang. So, therefore, we have our expanded nga expression. We have 1, then 8, 28, 56, 70, 56, 28, 8, and 1. So, for the A and B part, so as what I have said, si A kay decreasing ang iyang value from n, so A to the power of n, so that is A to the power of 8. Then, nag-decrease siya. 8 to the power 7, 6, 5, 4, 3, 2, 1, and 0. While si B is nag-increase siya from 0. So, 0, then we have B to the power of 1, B to the power of 2, 3, 4, 5, 6, 7, and 8. Okay? So, we observe that for each n, the expression of a plus b to the power of n starts with an, and the exponent of a in the succeeding terms decreases by 1. So, mata kong gingon. Nag-decrease ang exponent sa tong a, while ang exponent sa tong b is nag-increase siya. So, nga na lang, shortcut sa pag-solve. Dili na ta katong multiply pa ani. So, pwede na, diretsyo na ta answer sa iyang expansion. So now we are going to review the concept of combination. So I believe nga niagi na mo ani kanang probability, permutation, combination sa inyong previous nga mga math. So we are going to recall that. So recall that n combination of k, or can be written by this, counts the number of ways of choosing k objects from the set of n objects. So, for example, man magamit ang combination. So, for example, nakadaog ka sa isa ka contest. Then, there are 6 prizes nga pwede nimo pilian. And you're only allowed to choose 2 among those 6 prizes, you're only allowed to choose 2 prizes lang. So, how many combinations nga mga prizes ang imong makuha? So, si prize 1 o si prize 2 ra ba imong kwaon? So, pwede po si prize 1 o si prize 3 imong kwaon. Ana, si prize 2 o si prize 6 imong kwaon. So, since duha ra man imong pwede makuha. So, pila ang number of combinations ang mabuhat ana. Okay, so muna siya ang application sa combination. So, it is useful to know some of the properties of combination. So, we have n combination of k. So, that is if our k, or that is our object, is just equal to 0, so wala kay pilion, then, or that is the combination of n, then that is simply equal to 1. So, if n combination of 1 naman, or that is n combination of n minus 1, then the result will just simply equal to n. So, for example, naa kay 6 ka prizes, then you are only allowed to choose one of those 6 prizes. Then, how many combinations? So, of course, there are 6 combinations po. Pwede si prize 1 yung pilion, pwede si prize 2, 3, 4, 5, 6. So, that's why we have our answer here as n also. So, for number 3 nga properties ni combination is n combination of k is just equal to combination of n and n minus k. So, this is very useful later if you're going to use the binomial theorem na. Okay, again, n combination 0 is equal to 1, n combination 1 is equal to n, and n combination of k is just equal to n combination of n minus k. So these properties can explain some of the observations we made on the numbers in the Pascal's triangle. So we recall the formula of the combination of n objects taken k at a time. So that is n combination of k, or can be written by this one, over k is equal to n factorial over k factorial times n minus k factorial, where 0 factorial is equal to 1. So if you have 0, then 0 factorial is equal to 1. And for every positive integer n, n factorial is equal to 1 times 2 times 3, and so on padulong n. So for example, you have 5 factorial. So how do we solve that? So 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Okay? 5 times 4, that is equal to 20, times 3, that is equal to 60, times 2, that is equal to 120, times 1, that is equal to 120. So 5 factorial is equal to 120. Okay? Kaya nga na lang siya. So kung 3 factorial, that is 3 times 2 times 1. Okay? So for example, we have to compute 5 combination of 3 using this formula. We have 5 factorial over 5 minus 3 times 3 factorial times 3 factorial. So parehas na siya aning formula. So 5 factorial, that is equal to 120. 2 factorial, that is equal to 2 times 1, or simply equal to 2. 3 factorial is equal to 3 times 2 times 1, or that is equal to 6. So 2 times 6 ang sa kumbos. So 2 times 6 is 12. So 120 divided by 12 is equal to 10. So the same with 5 combination, I mean 8 combination 5. So that is 8 factorial over 8 minus 5 factorial times 5 factorial. So you can use your scientific calculator in solving this. So para din mo mag-expand og 8 times 7 times 6 times 5 ana. So pangitaas inyong calculator ang factorial nga sign. So that is equal to 56. So you may observe that the value of our 5 combination 3 and the fourth coefficient in the fifth row of Pascal's triangle are the same. So pareha sila answer. So 5 here is your n. Remember, this is your n, or this is the power of your expression. And 3 here is your term. Then the 10 here is your coefficient. So recall, so mag-add lang daw ka og 1. Kay fourth coefficient man daw ni siya. So sa fifth row, or n is equal to 5, mag-add ka 1 dari sa imong k, then ang answer ana mo na siya ang coefficient sa imong nga term. So our n is equal to 5 and our k is equal to, diba 3 man to. So you add 1, so 4, meaning fourth nga term. So 1, 2, 3, 4. So mo ni siyang 10 ang answer. So the same with sa 8 combination 5. So this is 8 ang atong n, then ang atong term nga gipangita is the 6th term, or that is 5 plus 1. So 8 ang atong n, then 6th term, 1, 2, 3, 4, 5, 6. So we have 57. So you may try to solve kung tahay 6 combination 1, 2, 2. Ana, 6 combination 2. So 6 combination 2, dapat ang atong answer ani kay sa atong 6 nga n, dapat ika-third nga term. So 1, 2, 3. So dapat 15 ang atong answer ana. So you try to solve that using your calculator. Okay, so these observed qualities are not coincident fundamental, and they are in fact the essence embodied in the binomial theorem, as we are going to discuss in the next section. So for the binomial theorem, again, this is applicable, or this is advantage siya sa ato ang n nga dagko nga mga numbers. So as the power of n gets larger, the more laborious it would be to use the Pascal's triangle, no? Kung n ang atong pancake, dako kay nga number, then ang atong triangle taas kayo. So for example, using the Pascal's triangles, we need to compute row by row up to the 30th row to know the coefficients of our a plus b to the power of 30. So imagine, no, dagan kayo taas kaya itong triangle na. And it is therefore delightful to know that it is possible to compute the terms of binomial expression in the degrees of n without going through the expansion of all those power less than n. So dili na ta kailangan nga mangita atong nga mga coefficients, no, by just using this binomial theorem. So I'll just skip this part. This is the derivation part and the proving part. So kamo na lay basa ana sa proving. So let's skip to the final or the general formula of the binomial theorem. So that is a plus b to the power of n is equal to the summation of n combination I times a to the power of n minus I times b to the power of I, where our I here is from 0 going to n. So nasabtan ra ang formula. So kasabot naman ta sa summation, no, nga kwan sa sigma notation nga akong na-discuss last previous module. So our katong gitulo na ko nga combination, so mo ni siya ang iyang application diri sa binomial theorem. So kani siya mo ni siya ang coefficient sa tong term. Mo ni siya ang iyang coefficient, diba, para sa tong 10 nga tong nakuha. So mo to siyang coefficient sa fourth term sa tong fifth nga row, or n is equal to 5. So the same, we are going to use that formula in finding the coefficient of that term. And while our a and b here is the katong a and b nato dere, and ang iyang power is si a, magkaubos siya since ang atong I man dere is mag-increase, diba? Mag-iterate siya from 0 to n. So for example, our n is equal to 5. So mag-start siya ni 0. So that is 5 minus 0. So a to the power of 5 di siya. Then kani kay b to the power of 0. So 1 ni siya makancel. Then first iteration 1. So that is 5 minus 1. So that is equal to 4. Then b is equal to 1. So nga na. So atong A magka-decrease while our B magka-increase. Okay? So let's have an example para mas ma-visualize ninyo tarong. So we are going to apply the binomial theorem in different examples. So example 7.4, use the binomial theorem to expand x plus y to the power of 6. So our n is equal to 6. Okay, then we are asked to expand. So x plus y to the power of 6 is equal to the summation of 6 combination I. So 6 here is our n kani, times x to the power of n minus 1. So 6 minus n minus I. 6 minus I times y to the power of I, where our I is from 0 to 6. So constant na jud ni siya, nga tong I mag-start jud siya ni 0. Then kani siya si n depende sa given. So first is our I is equal to 0. So 6 combination 0. So 6 combination 0 kani. So remember, this is a property sa combination. This is the first property sa tong combination, which is kani 6 atong n combination 0, so that is equal to 1. So the next property is n or 6 combination 1 and that is equal to n. Go remember, i-remember lang na ninyo. So again, 6 combination 0 is equal to 1. So that's why our coefficient here is equal to 1. Then our variables, so we have x, 6 minus 0, y to the power of 0. Okay, so that's why we have x, 6 minus 0, y to the power of 0. So 6 minus 0 is 6, so that's why we have x to the power of 6. Y to the power of 0 is equal to 1. Diba? Any number or variable raised to the power of 0 is always equal to 1. So next is we add, then we iterate. So atong I na dari, mahimo na siyang 1. Okay, so that's why we have 6 combination 1. 6 combination 1, again, the second property of the combination that is equal to n. Or our n here is equal to 6. That's why our coefficient here is equal to 6. Then, for our variable, we have x, 6 minus 1 na siya. Then y to the power of 1. So 6 minus 1 is 5. Then y to the power of 1 is equal to y. So that's why we have x, 5th, y. Next is our I will be equal to 2 na siya. Mag-add na po tag 1. So may muna siyang 2. So 6 combination of 2. So you're going to use the formula katong 6 factorial over 6 minus 2 factorial times 2 factorial. So you're going to solve that. So ang answer ana is 15. Or you can simply type it to your calculator, 6 combination 2. So the answer there is equal to 15. Next is the variable. So that is x, 6 minus 2 times y to the power of 2. So mana yung variable. Or just simply ikuan lang ninyo ang x or our a here kay mag-decrease ang ihang power, then ang atong y is magka-increase yang power. Okay? So since the expansion of a plus bn begins with k is equal to 0 or I, kaning k, yung pasabot kay I is equal to 0, and ends with k is equal to n, di ba? Kaysa combination kay k ug n manggod tong gamit. So that's why k na yung gigamit dere. Pero sa ato ang summation manggod kay sa atong sigma notation I atong gigamit dere for the iteration. So the expansion of n plus 1 terms. So the first term in the expansion, n0 times a to the power of n is just equal to a to the power of n. Diba? Kay combination of n0 is just equal to 1. Sa second term naman is combination ni n1 is just equal to n, where our n is equal to 6. So muna na akong i-explain ganiya. So the kth term of the expansion is n combination of k minus 1 times a n minus k plus 1 times b k minus 1. So k here, similar na siya sa I. So if our n is even, kung atong n daw, kani, just like this, is even, then there is a middle term, and that middle term is n over 2 plus 1 term. Okay? So, di ba? Remember, kung naatay n is equal to 6, ang atong number of terms anak kay mag-add tag 1. So, there are 7 terms sa atong expansion. So, meaning, since bungkig siya 7, na middle term. And the middle term is the fourth term. Or, that is n divided by 2 plus 1. So, n na to kay 6. 6 divided by 2 is 3 plus 1, 4. So, the fourth term is our middle term. So, for this example, 1, 2, 3, 4, 5, 6, 7. Atay 7 ka terms. So, ang ka-fourth term, ano siyang middle term? 1, 2, 3, 4. So, this is the middle term. So, there are problems that you are asked to find the middle term. So, this is the fourth term is the middle term. And if our n is odd, so for example, our n here is equal to 7 instead of 6. So our number of terms is 7 plus 1 and that is equal to 8. So add numbers siya dari. So nay last term dari nakabutang. And di ba wala siya middle. So ang middle ana nga term is katong duha ka tunga-tunga nga term. So that is n plus 1 over 2 and n plus 1 over 2 plus 1. So that is for example 7. 7 plus 1 is 8. 8 divided by 2 is 4. So fourth term kani. Then 4 plus 1 so fifth term so kani. So these are the two middle terms if ang ato ang n is equal to 7. So natay pang huli dere. Okay? So the general term is often represented by this one. So that is just similar ani kaning given nga formula. Okay? So let's have example nga magpangita siya sa unsa nga term. Okay, find the fifth term in the expansion 2x minus the square root of y raised to the power of 20. So if you're just going to use the Pascal's triangle, so you have to expand everything. So tama ni 20, layo kasi 20. So madugay ka. So by using the binomials theorem, so mas madali siya. So you just have use the formula kaning nk a n minus k b k, where n is the power kani and k is the term nga imong pangitaon. So k nato nga gipangita is the fifth term, and remember that k minusan nimo siya og 1. So that's why if you're going to find the fifth term, we are going to our k is equal to 4. Okay? Mag-minus ka og 1 kay since there are kung 20 ni siya, there are 21 terms. So the fifth term in the expansion of the fifth power corresponds to the k is equal to 4. So that's why we have 20 combination of 4 times our a. So our a here is 2x raised to the power of 20. Muna siya tong n minus k, which is 4, multiplied by our b, which is negative square root of y, raised to the power of our k, which is equal to 4. So 20 combination of 4, that is 4,845. Then 20 minus 4 is 16. 2 to the power of 16 is 65,536. So that is multiplied by x to the power of 16. Then we have the square root of y raised to the power of 4, that is equal to y squared. So nawala na si negative sign because negative, di ba namin siya imaginary nga 1, negative 4 to the power, negative 1 to the power of 4 is equal to positive 1. Square root of y to the power of 4 is equal to y squared. Then you multiply the constants, then you will find this answer. So that is for the, if you're going to find the fifth term. So what if you're asked to find the middle term of the expansion? So again, since this is, your n is an odd number, I mean an even number, then there will be only one middle term. So if add siya, na ay duha ka middle term. So since even ang atong n, so nara siya isa ka middle term. And that is 6 divided by 2 plus 1. So 6 divided by 2 is 3 plus 1, so 4. That is the fourth term, meaning our k is equal to 3. Okay, always ka mag minus og 1. So we are going to use the formula again, nga katong n over k times a to the power of n minus k times b to the power of k. So n is equal to 6, k is equal to 3. So 6 combination of 3 times a. So a na to is gonna say x squared raised to n minus k. So 6 minus 3 multiplied by our b, which is 3y raised to the power of k, which is equal to 3. So 6 combination of 3 is 20. Then 6 minus 3 is 3. Then you are going to distribute the cube sign. So x cube over 2 to the power of cube is 8 multiplied by kani distribute po 3 cube ug y cube. So that is 27 y cube. Then multiply 27 by 20, then divided by 8. So the answer there is 135 divided by 2 times our x cube times y cube. So this will be our middle term. So how about this one? So find the term involving x with exponent 1. So mangipahitaw na tong term nga ang value sa tong x kay ang power sa atong x kay equal to 1. So kani nga example, ang x kay raised to the power of 3. So pahitaw nato kung aha to nga term ang exponent sa atong x kay equal ra ni 1. So natay given nga expression. So that is by using again the general formula n over k times a to the power of n minus k times b to the power of k. So substitute lang nato. So atong n is equal to 8. Then k, so mo na to siyang pangitaon, katong term nga atong gipangitaon. Then we have our a, which is equal to x squared raised to the power of n minus k, or 8 minus k, multiplied by our b, negative 2y over x raised to the power of k. Next is we multiply 2 by 8 and kaning negative k. So 2 times 8, that is 16. 2 times negative k, that is negative 2k. Then here, you distribute lang nato si k. So 2 to the power of k, y to the power of k, and x to the power of k. I-distribute lang nato. Next is, di ba, if you have 1 over x squared and gusto nimo ipasaka ni si x squared sa numerator, then you just have to negate the exponent. So mo nang may mo na siyang x to the negative 2. So these are just equal. So similarly, if we want our x to the power of k to be in the numerator, then we just have to negate the sign of our x. So that's why we have x to the power of negative k. So aha man na siya nga part dere. So mo ni siya x to the power of negative k. So gi-add lang nato siya dere. So we have 16 minus 2k minus k. Then you copy the rest. So we have y to the power of k, then we have negative 2 to the power of k, then the combination. So negative 2k minus k, that is equal to negative 3k. So we have this expression. Okay? So the term involves x if the exponent of x is equal to 1, which means dapat ang ipangita nato kani daw siya kay equal ni siya ni 1, meaning our 16 minus 3k should be equal to 1. So that's why we have this equation nga 16 minus 3k is equal to 1. Then we solve for k. So balin lang nato ni siya sa pikas. So we have 16 minus 1 is equal to 3k. So 16 minus 1 is 15 over 3k. Divide both sides by 3. So we have k is equal to 5. So mo na siya itong substitute sa itong value sa itong k dere. So 8 combination of 5 minus 2 to the power of 8 minus 5. That, I mean, yeah, 8 minus 5. Then, I mean, kanina itong gamitan. Sorry. Dari na data kay simplified naman eh. Pero pwede ra pod kani mong gamitan. So for this kaning illustration, kana akong gigamit. So negative 2 to the power of 5 times x 16 minus 3 times 5. then y to the power of 5. So that is 16 minus 15, that is equal to 1. So itong x kay 1, then y kay 5. Then kani, negative 2 raised to the power of 5 times the combination, the 8 combination of 5. That is equal to negative 1,792. Okay, so this is the term that has uh, x with exponent niya nga equal to 1. Okay, so for your seat work, number 7, so use the Pascal triangle to expand these expressions. Then compute this combination. Then for your assignment, use the binomial theorem in expanding this expression. You find the two middle terms since this is an odd number, so there are two middle terms. Then for this one is find the constant term in this expression. So a term that has a kaning constant lang nga value. So unsa na siya nga constant or term ang answer ani. So deadline for the seat work and assignment will be posted on Creeper. So that's all. Thank you for listening.